Right, welcome back. Here's number 3. Now, first thing I notice when I look at number 3 is there is some kind of typo with the notation. So please don't be put off by this bit here. This is just that maps to arrow again. Okay, it just hasn't formatted correctly. So this is f maps x to the absolute value or modulus of 2x minus 5. Okay, so and x is any real number. And so yeah, don't be put off by this. And then it just says sketch the graph. Okay, right. So there's quite a few ways you can go about doing this. My preferred method in a situation like this is to draw the normal graph first, and then when y is negative, remember it's y, like this couldn't actually be negative. It gets more complicated if this is if this function is more complicated. For example, if I all of a sudden had to take away 1 after it, it becomes a bit more complicated. But for something as simple as this, the approach I'm about to show you should work just fine. And the approach that I'm about to show you does kind of work in general, but you have to be quite careful. So anyway, I will sketch some axes, and I will draw the graph y equals 2x minus 5 without the modulus. So that goes through minus 5, has a gradient a bit like that. So this is y is 2x minus 5. I guess that point there is 2.5. So that's what you've got. That's this. What the question actually wants is the modulus of y, right? The modulus of 2x minus 5. So you're asking whenever this is negative, y being negative, not x. X can be anything you want. And I mean, it even said, look, x can be anything you want. X can be negative. We're asking about 2x minus 5. That's all of a sudden now not allowed to be negative. If it is, you flip it, you make it positive. Right, that's what that modulus sign does. The modulus sign says whatever's inside, if it's positive, fine. If it's 0, fine. If it's negative, make it positive. So this part here, we go over it again in blue. That part there, that is positive, or 0. So that stays the same. As soon as x is less than 2.5, y goes negative. So all you do is say, look, all of this, it would be the same numbers, but positive, which is not a particularly mathematically precise thing to say, but I hope you get what I mean. Okay, so it would be the same, but positive. So basically just flips, like a mirror. So of course it's now going through positive 5. And then if you actually want to then have a nice, neat answer, you might draw it again. And I mean, I might as well. It wasn't that much effort. You know, I'm just going to put a V shape basically, and write 2.5 and 5. And write y is mod 2x take 5, like that. And have I done everything in the question once? Show the coordinates of the points where the graph cuts or meets the axes. Yes, I have. There you go. And hopefully you can imagine that this could be quite fast, right? So it doesn't need all of this, or all of me talking about it. Okay, there you go. That's that one. Right. B. I might need to bring my answer to A back. We'll see. Right. Part B anyway. So I need to solve f of x, so f of x equals 15 add x. So if you look at the original picture, 15 add x will, well, it has a gradient of 1, and it goes all the way up at 15, it's definitely going to cross this, and it's definitely going to cross this, because that one there has a steeper gradient. So you can definitely set it equal to both of these things. So what you're going to do is you're going to write 2x minus 5 is equal to 15 add x. Now this is 2x minus 5 if x is greater than, I guess, or equal to 2.5. So we've got an equation to solve. That's basically it crossing this one here. That's it crossing that one. So we'll solve that. So what have we got to do? Take away x, so x equals 20. What you should always do at the end is check your answers, of course, as well, because these can be quite tricky, especially the more complicated ones. We've also got a different one. We've got the negative of this. So that's really important. The modulus of a number is the negative of it if it was negative to start with, if that makes sense. So, for example, let me use a different color. The modulus of -3 is the negative of -3, which is 3. So this is how this. If you look up the definition of the modulus, you'll see it's kind of splits up into, it either equals x or it equals -x, and it equals -x if x itself was negative. So what that does is it always produces a positive answer. Anyway, hopefully I've not said anything too confusing there. I'm confusing myself, so I'll just kind of get on with this. So 2x minus 5, the negative of that is minus 2x add 5. So that's this is like two possibilities. That's still the 15 plus x. Now this equation is what we have if x is less than 2.5. Now how you know if a solution is not valid is, say we got an answer to this that then violates this, then it wouldn't be valid. If you notice 20 is greater than or equal to 2.5, so we fully expect that that'll work when we check. Anyway, let's see what we get here. So I'm going to add 2x and take away 15. So minus 10 is 3x. So I get x is minus 10 over 3. And that is less than 2.5. So I'm prepared to give that a tick. It's in this situation where I might want to use a calculator. Now, I haven't quite worked out how I would also put the calculator on the screen. I might actually try that now. I think I can do that. There we go. Wow, this is quite clever, isn't it? I don't say so myself. Right, that just slots in nicely there. And now it looks like I'm looking at the calculator. Okay, I guess it means I have to actually use this calculator, which is a bit awkward, but never mind. So let's try it. So modulus sign, where's that on this tiny screen? Oh, I'll make it bigger. Right, I have oh yeah, it's apps, isn't it? Apps. Oh, hang on a second, I've just worked out I need to actually be on the calculator. Right, that won't happen again. 2 times 20 take away 5. Is this the same as 15 add 20? Let's see. It is. So the first one works. Super. Right. Let's try it again for the other one. I have to do 2 times minus 10 thirds. And then take away 5. So the question is, and this one won't necessarily be instantly obvious, so if I do 15 add minus 10/3, do I get the same answer? I mean, it looks like I will. Yeah, there you go. So we've checked it. That's how you would do that. And now I think I can just make the calculator invisible by pressing this button. Well, there you go. Good, okay, there we have it. We can, so that's the answer to part B then. I guess now we're looking at the next part. So we have part C. G of x is equal to, I'm just going to write it like this straight away, by the way. Again, it's a little typo. It should be the maps to arrow. It wouldn't be, the vertical line would not be as long on the maps to arrow. So that's definitely just a little typo. X squared, take away 4x, add 1. And we've got some key information here. So x is a real number, but it is between 0 and 5, including 0 and 5. Okay, so that means you can only put values between 0 and 5 into G. This could be important. Okay, it's really important that you realize that. So let's have a look at f of g of 2. So can I even put 2 into G? Well, yes, I can. So I mean, it would be a stupid question if it wasn't, but it's worth having that thought. Okay, so let's work out G of 2. So this is f of whatever this is. So I'm not going to get the calculator on the screen now, but I will use my actual calculator. So 2 squared, take away 4 times 2, add 1. It was minus 3. Okay, f of minus 3, and f was that. So I need to do 2 times minus 3, take off 5. So this one I'll do in my head. So minus 6 take away 5 is minus 11, and the modulus of minus 11 is 11. So I think it's just 11. I feel as though that's I feel like I've been lulled into a false sense of security there. Let's see. This one I might have to do some cuts, or we might just leave this in. Depends on depends on how awkward it is. Aha, 11 is the answer. Super. Right. Okay. D. Find the range of G. So we want the range of G. So what that means is we want all the possible values that G can output. So what is going to be worth doing is either drawing the graph and having a look at it that way. What you want to do is you want to check. I guess in general, so let's talk about this very generally, because I mean this is true no matter what. Even if it's not a quadratic, you should check the endpoints, right? You should check the endpoints, and then you should see if there are any maximums or maxima or minimums or minima within that range. So what I mean is, I'm just going to sketch some possibilities. Okay, so between 0 and 5, it could go like that. And then it's just those answers. Between 0 and 5, there's another possibility, right? It could literally, between 0 and 5, it could do this. Now, if you only checked 0 and 5, you would see that they gave the same answer, and you'd be wrong if you claimed that was your answer, because you actually need to know about this minimum here. And you could have something more complicated. I'll draw one that's not a quadratic, just a totally random one. So I've got my 2 endpoints. It goes up and down like that. And so, okay, knowing about the endpoints is good, but really I need to know what this is and what this is, because that covers the entire lot of output. And so this now is an exercise to do with differentiation, okay? Or because it's a quadratic, we could complete the square and see where the minimum is that way. But anyway, let me just answer the question, and then hopefully I'll make it clear through how I've done that. So first of all, let me just remind you, we're looking for the range of g, and I'm going to write y equals g of x, which is x squared, take away 4x, add 1, and this is only between 0 and 5. So outside of 0 and 5, it isn't even defined. So what does this look like? Well, first of all, let's look at g of 0. So that's 1. And g of 5, 25, take away 20 is 5, add 1 is 6. So, you know, you could be very tempted to say, well, it goes between 1 up to 6. And maybe that's the answer. But what we need to do is make sure that it doesn't go above 6 or below 1 in the interval 0 to 5. Okay, so what we're going to do is we're going to do g dashed of x equals 0. So this is me looking for a stationary point, and because it's a quadratic, it's going to, well, it's a positive quadratic, so it's going to be quite clear if it's a minimum or maximum. Okay, so we want to solve this equation. So 2x take off 4. So I've just differentiated this. 2x take off 4 is 0. 2x equals 4. X equals 2. Oh, so there is a minimum or a maximum in this interval. Now that means it's going to be, I mean, it's going to be either, it's going to be less than 1, right? It's going to be less than 1 because it's got to be a minimum. Why has it got to be a minimum? Because it's a happy quadratic. It's a happy parabola because it's positive. It's a positive parabola. So what I'm going to do is put x is 2 into this to work out the that minimum. Okay, so I'm going to work out. So this. So I guess if I write, there is a stationary point at x is 2. Now there's technically speaking, although I feel fairly confident to suggest that you can get away without doing it for this, but there is technically speaking a bit more work to be done to say, look, it is a minimum. You know, you have to differentiate again, and show that the second derivative is I guess positive. So there's a stationary point at x equals 2. I'm just going to say it's a minimum. Although, to be fair, when you differentiate this, again, you get 2, and 2 is positive. So there you go. It's a minimum. So it's a minimum. What is this coordinate? Well, it's 2, and then 2 squared. Let me just type it in. Well, have we not already answered it? That's what we did just before, isn't it? 2 squared. Take off 8, and then add 1. It gives -3, doesn't it? So what that means is, let me just draw it here. Remember, it's actually only between 0 and 5. So there's 0, there's 5, and there's a point here 2. Use a different colour. Now at 0, it was up here at 1, and at 5, it was all the way up at 6. So this is 1, and this is 6. And so, very naively, when perhaps you got this wrong, you maybe would just put 1 to 6. But here's the point. At 2, it's actually down here at -3. And it's really important that you're always aware of that. It's not just to do with the endpoints. The endpoints are useful and can sometimes help you with the answer. I mean, obviously, knowing that 6 there helps with the answer. But anyway, look, this is what it looks like. It's literally a minimum there, and then goes back up like that. And so this is the range. With this setup here, let me put an orange box around it. With that setup there, you can get any value out that is between -3 and 6. If you want to get -3, you put in 2, right? If you want to get 6, you put in 5. If you want to get 1, you put in 0. And then the rest you'd have to work out. But you can see that the range must be -3 to 6. So all that's actually left is to then actually write the answer. So the easiest way of writing it is just g of x is, and it is equal to, as well, it does actually equal, so it's everything and including -3 up to and including 6. I really hope that my explanation there of why you have to be so careful with this and why all of a sudden we've got differentiation involved is, I hope my explanation was clear, and that this picture here helps you for harder questions in the future like that. Anyway, as I say, and I've said it in the other videos as well, any questions, anything you want to say, you can put it in a comment.